वेलकम बैक माय डियर स्टूडेंट्स, वेलकम बैक। स्वागत है आप सभी का। यूर ऑल वेलकम। वेरी हैप्पी गुड महीना शिवा तरुण एंड ऑल। कैसे हो आप सभी? हाउ आर यू ऑल बेटा? कंफर्म मी बेटा, ऑडियो वीडियो क्रिस्टल क्लियर टू ऑल ऑफ यू। कैन वी प्रोसीड? कैन वी प्रोसीड माय डियर स्टूडेंट्स? Still waiting. Good sir, how are you all? Clear? I am also fine beta, very good. So now we are in lecture number 34, doubt clearing session. Okay, so I received many doubts from your side beta. I will discuss all 100% doubts. Okay, received. So once again, you're welcome. As you all know, this side Gaurav Shrivastava sir from Engineers Institute of India, with 14 plus years of teaching experience as GATE chemical engineering author, educator, multiple GATE top ranks like AIR under 100, under 50, like current year AIR 43 in GATE 2025. Okay, so I received many doubts, and after seeing a few doubts, repeated doubts are there that asked by more than one student. And after compiling these doubts beta, I got question number 114, 115, 116, 118, 123, 148, 151, 165, 166, 168, 169, 170, 195, 197, 198, 199. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Total 16 questions I received. And one theoretical doubt also received. And I think that doubt asked by who? It's Anushka Viswas. Are you there with Anushka Viswas? 172 beta, I didn't receive in message beta. But don't worry, after completing these all, oh, 172 is also there. Yeah. Wait, let me add that question to my slide. Okay, 172 number. 172, where are you? 171, 70. Oh, this one. It's very easy बेटा महीना, बहुत ही आसान. It's very easy. 172 भी sir. Okay, wait. Adding. Okay, so 172 also added. और चलो 172 से ही start कर देते हैं भाई. Okay, just added 172 number. Okay, so 16970 here, 172 is also present. So total number of questions, that means 17. Okay, no more doubts. Can we start? And one theoretical doubt was from Anushka Viswas. Anushka asked, sir, for positive C, first I am going to discuss Anushka's doubt. So Anushka Viswas. Anushka Viswas asked, sir, for positive order and same conversion. Okay. So for positive order and same conversion, VCSTR is greater than VPFR. Then why CSTR is more preferred then why CSTR is more preferred for positive order reaction. Okay. So first tell me beta Anushka, the doubt that you asked, where you had seen this doubt beta? Very happy good evening beta Anushka. कहाँ आपने देखा कि आप CSTR को प्रेफर कर रही थी? Can you tell me? Anushka, can you tell me beta? For which case you had seen? For which case you had seen that you are preferring CSTR for positive order reaction, even if the volume is more. Can you tell me beta? One more theoretical doubt is there. For low temperature CSTR more preferred, positive order reaction, high temperature PFR more कहाँ से लिखा बेटा ये सब? It gives same conversion as well for same residence. Hmm? कहाँ से नोट कर लिया ये सब बेटा? See, if someone asks this question in GATE examination beta, okay, then this statement you are going to tell statement is wrong. Statement is wrong. Okay, statement is wrong. This should be your answer. This should be your answer, that you are not going to recommend CSTR if they are asking which one is recommended for this given reaction. So just you are going to tell that, yeah, PFR you are going to prefer PFR as the volume required for same conversion is low. But if someone asks in interviews, then the answer that you are going to give is totally different. So you have to tell, yeah, sir, on theoretically, whenever we are going to calculate the volume of CSTR, we are getting more in comparison to PFR. But even in many actual operations, in industries, in many actual processes, we are using CSTR. We are using still CSTR. Okay, practically, if you are going to see in industries, so still we are using CSTR. Why? So many reasons behind it. Like maybe your reaction is exothermic in nature, and if you are going to do this in PFR, hot spots may be there, uneven temperature distribution, uneven heat distribution will be there. But in CSTR, these things are uniform. These things are uniform. So you can also use this CSTR because its a construction and working is very easy. Construction and working very easy. Construction and working very easy. So we can use more CSTR in series so that we can achieve a similar conversion as we are getting in case of PFR. Also, whenever you are going to make PFR of V large, it is difficult to operate or difficult to make, and it is costly one. It is costly one. You need to arrange multiple parallel pipes, and also PFR behavior is just on paper. PFR, actual PFR is not available. Actual PFR is not available. Plug flow is not available. It is only on paper. So that's why in industry beta, for most of the operations, we are going to choose CSTR, not PFR. Also, you can see for auto catalytic reaction, you can also choose this CSTR if some auto catalytic reaction is there. So these things only beta you can say in interviews. If they are asking in gate examination, you are going to tell no, we are preferring PFR for this given case. Is it crystal clear to all of you beta? Is it crystal clear beta Anushka? Can we proceed my dear students? Can we proceed? Everyone just confirm me beta. Can we proceed? समझ गए, समझ में आ गया हाउ टू गिव आंसर बेटा एवरीवन? Okay, very good, fantastic, mind blowing, super. So this problem was also clear, sir. Thank you, very good, beta. This one also asked by Anushka. और किसने किसने पूछा है? 172 by Anushka. Anushka, I think only Anushka asked. No, no, it's Mehna. It's Mehna. It's Mehna. So see, beta Mehna, it's very easy question. Yeah, very easy. Liquid phase isomerization of O-xylene to P-xylene using zeolite catalyst was carried out in a CSTR. Three sets of kinetic data at different temperature and stirring speeds were obtained. The operating condition at which the reaction rate is not controlled by external mass transfer resistance is C. If the reaction is catalytic, and clearly you are seeing zeolite catalyst is there, and the nature of zeolite is porous. The nature of zeolite is porous one. So suppose this is your catalyst. This is your catalyst. These are pores. These are pores. These are pores. Okay. Now, when you are going to see beta, one resistance will be there outside because two phases are there. One is liquid and that catalyst is solid one. So one resistive film will be there, mass transfer resistive film. Now, here they are writing the operating condition at which rate is not controlled by external mass transfer. You know, the thickness of this film you can decrease or increase if you are using this CSTR, and if you are uh, increasing or decreasing the speed of this stirrer. And one more thing, better here you can give two interviews that when we are going to use some flow reactors and we are using some catalyst. So if you are using that catalyst like in suspended form, you want to use it like trickle bed reactor, that was packed bed reactor with catalyst. So but if you want in suspended form, then it is not possible in case of PFR because they are going to settle down. So for that purpose also we are going to choose CSTR. And you know na beta, when in your examination they are asking questions relating PFR or they are asking questions relating PBR. So what is PFR? This is packed sorry plug flow reactor, and PBR is packed bed reactor. And for both cases beta, the same design equation you are going to use here. Just V by Fa naught will be present, and here W by Fa naught will be present. So if you are seeing these type of questions, 100% same, 100% same their calculation, everything. Just in place of V you will see W, and in place of Ra you know not different Ra single dash, double dash, triple dash. So you are using that Ra that is based upon unit weight now. Okay, now see this question beta. So clearly, when it is writing here that external mass transfer is not going to control, that means further increasing or decreasing the speed of this stirrer is not going to affect the rate. It is not going to affect the rate. Now let me check. So steering speed 1000, rate is 20. 2000, rate is more. 3000, oh my god, see. Here clearly this data is going to give us that there is no, because same temperature 500 500, and you are changing from 2000 to 3000, but still the rate is not changes. That means here no mass transfer limitation. So let me check 500 and 3000. Yeah, see 500 and 3000 A is the right answer. But let me check more options. So 600 1000, no, here see 1000 to 2000 rate changes. That means mass transfer, external mass transfer is controlling rate there. But here see 0.047, yeah, this is also correct. See here, changed, no, it is totally wrong. So one more answer can be here, that is 600 Kelvin and 3000 Kelvin. But here with 600 1000 given, so no. So only out of these two, one is present in options, that is 500 Kelvin and 3000 RPM. So A is the right answer beta, where rate is clearly not controlled by external mass transfer because you are changing the stirrer speed, but still the rate is not changes. Is it crystal clear beta? Mehna, can we proceed beta? फटाफट बताएंगे, फटाफट, everyone please tell me beta, is it crystal clear? Can we proceed, my dear students? Crystal clear, sir. Okay. Now, this 115 was asked by many students, I think. So, who asked? It's Mehna, and also Shayan Mukherjee. Shayan Mukherjee, are you there, beta? Are you there? And few more students. So, see here. The problem is very, very easy. Asked in 2025, same year, beta. The reaction is forming products with reaction rate, third order, and many students not attempt this question just because of third order. I already told to my students that, beta, please remember these integration values directly. Or you can also deal these integrations if they are simple, constant density systems. Only in case of variable volume system, the integration will be little bit complex. But if the reaction is a constant density system, very, very easy. So you have nothing to do, beta. They are telling you the rate that is K C A cube occurs in an isothermal PFR operating at a steady state conversion at two axial locations given value of L1 by L2. Why you are worrying, beta? First thing you know now, if you want to check what is the value of volume till this, so you can write it's zero place, it's one place, it's two place written here. So write it zero, it's one, it's two. Suppose I'm representing locations as 0 1 2. So the volume that is from 0 to 1, and here the volume that is 1 to 2, that means only this volume, but only this volume. Okay, so when you are writing v 0 to 1, it can be written as the cross sectional area multiplied with that L1. And here, if you are writing 1 to 2, my dear students, again the area will remain same, cross section, and multiplied by L2. So if you are going to write expressions for V01 and V12, then in order to get this, just if you are going to divide these two after getting, so see, you are going to get your answer. But nothing is special here. Here nothing is special, just mathematical dealing. Yeah, you know design equation, just you are going to do mathematical dealing. Nothing is special. Okay. So now see for first one, and when you are going to go do this division, definitely the k and all other constants like v naught or c naught, everything will be cancelled there, so no need to worry about that, like f naught also, because f naught for this section and for this section will remain same, because f naught here at the start, if you are going to write here the v naught and f naught, it will remain same for both the sections. Okay, and you know the limit values. If you are going to do limit here, then that will be 0 to, here the limit will be 0 to 0.3, because written up to this section conversion is zero point 0.3, and for this section it's 0.3 to 0.6. और क्या है बेटा इसमें, क्यों नहीं लगा पाए बेटा मैना एंड शान मुखर्जी? इट्स वेरी वेरी इजी बेटा, इट्स वेरी वेरी इजी. ओके, सो नथिंग इज स्पेशल यार, कुछ भी स्पेशल नहीं है यहाँ. सी, सो इट्स V01, so by fa naught, and that can be written as 0 to 0.3, then here dxa upon kca cube, so we can write kca cube, so ca naught cube 1 minus xa cube. Further writing, we can write as v naught 1 equals to fa naught upon kca naught cube. These all terms are constant here, so no need to worry about these terms. No need to worry about these terms. Okay, so dxa upon 1 minus xa raised to power 3. Now everyone know uh, its integration is, इसका इंटीग्रेशन क्या आएगा ये आप सभी को पता है यार, बिकॉज इट्स 1 माइनस एक्स रेज टू पावर माइनस थ्री, so it's minus 3 plus 1 minus 3 plus 1, so it's minus 2 in denominator and minus 2 in numerator, so minus, then 1 minus x, so minus minus cancelled, so 1 by 2, 1 minus x raised to power minus 2, so you can write 1 by 2 v not 1 as fa naught by k ca naught cube, and here you can write uh, 1 by 2, so 2 I can write outside, and 1 minus xa raised to power minus 2, so I can write 1 upon 1 minus xa square, and limit is 0 to 0 0.3. Okay, now just put these limits here. So v01 equals to fa naught by 2 k ca naught cube, and now the upper limit will give you 1 upon 0. 1 minus 0.3, that means 0.7, so 0.7 is square, and lower limit will give you just 1 beta. So this is v naught 1, इसे equation 1 मान लेते हैं. Similarly beta, you can write for v1 to 2, and this time again the integration will remain same. So here you can write again fa naught divided by 2k ca naught cube, but this time the limit changed, that is from 0.3 to 0.6. So by putting 0.6 upper limit, it's a 1 by upper limit 0.6, so 1 minus 0.6 will be 0.4, so 0.4 square, and now lower limit 0.3, it will give you 0.7 square. Equation number 2. Now just divide equation 1 with equation 2 here. Equation 1 by equation 2, it will give you v naught 1 to v1 2, and that can also be written as L1 by L2. Just you had seen it better. And after this, see, these terms will be cancelled, only this will be remain 1 upon 0.7 square minus 1, and upon 1 by 0.4 and 0.7, 0.4 square minus 1 by 0.7 square. And tell me beta, how much you are getting? कितना आ रहा है, कितना आसान है, देखो ना. Just see beta, approach, integration, everything is very very easy. Okay, can you tell me beta answer? How much? 0.24727. 0.24727. So they are asking up to 2 decimal places. So up to 2 decimal places you can write 0.25. Tell beta Mehna and Shyan Mukherjee, is it crystal clear beta? वेरी वेरी इजी ना बेटा, ऐसे क्वेश्चन लगा लिया करो बेटा मेहना, थोड़ा सा वापस से अप्रोच करो, सोचो, नथिंग स्पेशल यार. ओके बेटा, कैन वी प्रोसीड माय डियर स्टूडेंट्स? ओके, फैंटास्टिक, माइंड ब्लोइंग, सुपर यार, सुपर सुपर. आगे बढ़ा जाए. ओके, सो दिस वन आल्सो आस्क्ड यार 114. हु आस्क्ड, लेट मी चेक नेम. इट्स कौन है भाई ये? Yeah, it's Mehna, asked by Mehna, and 114. Sir, I got answer, but don't know it is if it is correct or not. But if concept is right, then answer is absolutely correct, beta Mehna. Okay, so feel confident, beta. Be confident. Okay, and also asked by, no, only one student asked. Okay, so beta Mehna here also nothing special. अच्छा, इसका आपका आंसर आ गया है. आंसर हम दिए नहीं थे क्या? Its answer is beta, I think it's second order and 0.15. Is it same? यही आंसर आया अगर आपका, तो हम इसे छोड़ दें. Tell me beta मैंने also got same answer. If different answer, then ask me to explain. You want explanation, then write explain sir. Everyone tell me beta. थर्ड ऑर्डर आया था, सो थर्ड ऑर्डर ही होगा यार. लेट मी चेक आंसर यार. आंसर की तो इसकी है यार. रुक जाओ, इससे हम बुक से निकाल लेते हैं. या बेटा थर्ड ऑर्डर है. सॉरी सॉरी, इट्स नॉट सेकंड ऑर्डर, इट्स थर्ड ऑर्डर. आंसर इज थर्ड ऑर्डर. तो थर्ड आया है तो बिल्कुल सही है आपका. So I also got same to same beta. Same, please tell me. Anyone wants explanation? Tell me again beta Mehna. Anyone wants explanation, then write explain sir again. Everyone please tell me beta, because it is very trial and error is there. In this you have to do trial and error, because they are telling non-zero. So general orders are 1 2 3. Yes sir, explain. रुक जाओ यार, इसको उठा लेते हैं, कुछ कटिंग्स इसकी हमारे पास थी. वेट. ओके. ये चलो आ गई. नाउ सी बेटा, here again you are going to you start this with their respective design equation. This is for nth order, and after integration you will get this. ये इंटीग्रेशन की वैल्यू है, दिस इंटीग्रेशन वैल्यू बेटा. ओके. Shivatron sir, same issue sir, got answers for question but don't know whether the approach is right or not. Just want to see your approach sir. Okay beta, just see my approach and now try to get or feel more and more confident beta. Okay. So its integration value here I am writing beta. Now two cases are there in your problem. This is your case number 1. This is your case number 2, my dear students. So two cases are there, and you know, with the help of CA is equals to CA naught 1 minus XA. If you are going to rearrange, you can write XA is equals to CA naught minus C upon CA naught. Okay. So in this manner, with the help of these concentrations, here the conversion is 0.5, and for second case the conversion will be approximately 0.7225. Okay. Now you have to calculate the value of n. So see here, if you are writing tau and k also there, so tau k, so it becomes equals to what? Tau k becomes equals to what? 1 upon c a naught raised to power n minus 1, and then this complete integration value beta. Okay. And in both cases they told you that the value of tau k will remain same. इसकी वैल्यू दोनों में आपको सेम बताया है, that it is not going to change. It is not going to change. So just when you are going to divide, then it will give you 1, and here instead of this ca naught raised to power n minus 1 c, for second case ca naught is twice of first one, so you will get 1 upon 2 raised to power n minus 1. कुछ ऐसा आपका आ जाएगा into that integration value, and here different one, and here also you will get integration value for different one. ओके. जो इंटीग्रेशन की वैल्यू है आपकी दोनों साइड में आएगी, सब कुछ कैंसिल हो जाएगा, केवल ये इंटीग्रेशन वाला टर्म बचेगा, ओनली इंटीग्रेशन टर्म, एंड बिकॉज ऑफ दिस कंसंट्रेशन डिफरेंट आर देयर, सो दैट विल बी देयर. ये आपके पास बच जाएगा. बोलो समझ में आया कि नहीं आया? आर एबल टू अंडरस्टैंड बेटा? टेल मी. सो ये वाला कौन सा होगा? ये वाला पॉइंट कन्वर्जन 0.5 वाला होगा, एंड दिस वन कन्वर्जन 0.7225 वाला. ओके. Why? Because when you are seeing 0.5 case and this one, and after comparing these two, clearly you can see here for this case the concentration is twice. So if this is twice, so after rearranging you can write I 0.7225 comma n equals to 2 raised to power n minus 1 I 0.5 comma n. Now in this you have to put the value of xa just here, one time 0.5, one time 0.7225. You will get this and this value beta, and after that just you are going to do trial error method by putting n equals to 1 2 3, because here they are writing non-zero integer. So integer means either it can 1, it can 2, it can 3, but wait, it order can be 4, order can be 5, order can be 6, but order more than 2 are rare. These are rare cases. Order more than 3, it's very rare cases. Okay. But still if someone asks you is it possible, so you have to tell yeah, order 4 is also possible, but for elementary max order is 3. Okay. But here they are not writing anything, they are writing like elementary. No, nothing written there like this is elementary reaction. Okay. So If because if elementary automatically it will be 1 na. If it is elementary automatically it will be 1, but mostly just you have to check for 1 2 3. If not 3, then very very difficult paper is there. That means again you need one more trial and error by putting 4 here. Okay, so see all things here, all things here. If you are going to put 1, see left hand side is not equal to right hand side. By 2, again not equal. By 3, see it's same. Left hand side and right hand side same. So clearly the order will be 3. By 4 you can also see left hand side is not equal to right hand side. So n is equal to 3 satisfies. That means order is 3. N is 3 by trial and error beta. Now for n equals to 3 you can solve either by using case 1 data or by using case 2 data, because you got this order for both the cases. So just put here values and just one equation, one unknown, you will get the value of k is 0.15. Okay, is it clear बेटा? मैं ना क्लियर है? फटाफट बता दो, आगे बढ़ जाए. And now again बेटा सॉल्व दिस प्रॉब्लम अगेन आफ्टर दिस लेक्चर बेटा. मैं ना समझ में आ गया, अच्छी बात है, लेकिन इस लेक्चर के बाद एक बार फिर से ट्राई करेंगे बेटा इसको. ओके, क्रिस्टल क्लियर. चलो आगे बढ़ते हैं. दिस प्रॉब्लम इज वेरी वेरी इजी यार. ये तो प्रॉब्लम, दिस प्रॉब्लम वाज सॉल्व बाय मी ड्यूरिंग एग्जामिनेशन इन लेस देन 30 सेकेंड. ओके, लेस देन 30 सेकेंड. Because once I got 99, immediately tick and आगे बढ़ गया, move on. See, problem is very very easy. A zero order reaction, very good. क्या ही बात है, it's fantastic. It's zero order reaction. Who asked? 116. 116 asked by Shayan Mukherjee, Devarsh Agnihotri. Shayan Devarsh Agnihotri and Kia Das. Kia Das, are you there beta? Kia Das, are you there? And many more. Okay, so see beta, it's very very easy. R is equals to K, and it is also written as equals to 100 mole per liter per minute. This is the rate given. Okay, a zero order gas phase reaction with rate this is carried out in a mixed flow reactor of volume 1 liter. Volume is given as 1 liter. Pure A is fed to the reactor at a rate of 1 mole per minute. Okay beta, क्या था? Now just see here beta. So 1 mole, it's molar flow rate na beta. So it's Fa naught and it becomes equals to 1 mole per minute. This is Fa naught. At a time t is equals to 0, the outlet flow is stopped while the inlet flow rate and reactor temperature remain changed. Okay. Okay, that means time t equals to 0 per outlet flow is stopped. So I'm not going to show here outlet flow, but inlet flow is still there. That is Fa naught is equals to 1 mole per minute. And because this is gaseous reaction, so you can close CSTR from here, and its volume will remain same because this is the volume of CSTR in their respective design equation, and this is also equal to volume of this reaction mixture. Okay, assume that the reactor was operating under steady state before the flow was stopped. The rate of consumption of A at time t equals to 1 minute. It's very very easy. It's very very easy. So just you have to take material balance over reactor. Material balance over reactor. It's very very easy beta. It's very very easy. So what is material balance? In minus out minus rate of disappearance of A into volume, and that equals to rate of accumulation of A within the tank. Okay, within the tank, and clearly it is a is forming B is given. So just you can write here is equals to d Ca by dt. Can we write like this? No, it is not correct. No, it is not correct. It is not correct. Why? Because you are going to write molar flow rate. So here it's Na, dNa by dt. Okay, dNa by dt. Now further moving, because the volume is 1, so Na can be written as Na by V can be written as Ca, and because volume is 1 here, so you can write Na equals to Ca. That's why here you can write Na equals to Ca. So further moving, we can write dCA by dt, and that equals to FA naught minus RAV. Further moving, FA naught is how much? It's 1, minus the rate is 100, volume is 1, so it's minus 99. Or further moving, you can write minus dCA by dt, that means rate of change of concentration within the tank for A is minus 99, and clearly in right hand side no time function is there, so clearly at any time whenever you are going to see, it will remain same as minus sorry 99, it will remain same as 99. So which one is correct? D is the right answer. Is it correct? Is it crystal clear? Can we proceed, beta? जल्दी जल्दी बोल दे जाओ, because still many questions are there and I want to discuss each and every question. Tell me, beta, can we proceed? Can we proceed, my dear students? Everyone crystal clear? Very good. And this one, beta, ये तो बहुत ही आसान था. This one asked by who? Nothing special in this question. यार पूछने वाला था ही नहीं ये तो. Shayan Mukherjee. Only Shayan Mukherjee asked this question. Shayan Mukherjee, beta, are you there? Shayan Mukherjee, are you there, beta? Hmm. So problem is very easy, beta. Crystal clear, very good, beta. See, reactant A decomposes to products B and C. Okay, so reactant A is here. You are going to decompose it to product B and C in the presence of an enzyme in a well-stirred batch reactor. Okay, clearly enzyme is not going to consume there, just acts like a catalyst there. So minus R is equals to 0.01 Ca and upon 0.05 plus Ca, okay, mole per liter per minute. If the initial concentration of A, that is Ca naught, is 0.02 mole per liter, the time taken to achieve, what is the value of T to achieve 50% conversion, that is 0.5 in minute. Okay, and it is written as batch reactor. So very easy, बेटा कुछ करना ही नहीं था इसमें, क्यों पूछ लिया रे भाई. Just you have to solve this rate expression. Okay, this rate expression इसी को आपको solve करना है, and after that you will get your answer. Can you solve it, बेटा? Solve करके बताओ जरा. Tell me. Tell me answer, my dear students. Because nothing is special, just you have to solve that simple differential equation here. Hmm. Very good. 4.47 is the right answer. So ये सभी लोग कर लोगे ना? No need to solve for my side. Hmm. You can also solve just in terms of CA, beta, because when XA is zero point 0.5, then CA will be half, that means 0.01. So you can also take limit in terms of CA. No need to convert in terms of XA. XA के terms में convert करने का जरूरत ही नहीं है बेटा. Okay. Limit 0.01 to 0.02 to 0.01. So after solving T will be 4.47 minute. Okay. And who asked 1 2 3 1 2 3 1 2 3? शयान मुखर्जी. देखो क्वेश्चन पूछे बेटा शयान मुखर्जी और आप लाइव में हो ही नहीं यार, तो कैसे समझोगे? आपने पूछा भी इसमें क्या डाउट है, कैसे डील करें बेटा इसे? शयान मुखर्जी, आर यू देयर इन द लाइव क्लास? If you are asking some doubt better, then you must be present during live class, otherwise what I am going to discuss in this question. So just see beta, other students and Shihan Mukherjee in recorded lecture. If you are going to see this lecture, then see beta. Whenever you are going to make these type of diagrams, and if they are telling you that in both branch the xa1 will remain same, if they are telling you like this, xa1 and xa2 both are same, so for that purpose this is also become equals to xa1 only become equals to xaf when xa1 equals to xa2 also, ये दोनों तभी समान होंगे जब ये भी सेम होगा. So for same conversion, just you have to remember one thing, that v by fa naught of these two lines, because pfr here, pfr here, so v by fa naught of these two lines must be identical. Okay, and nothing is special. If it's still doubt, again you can ask me, beta. Everyone, please tell me, any more explanation required, or is it crystal clear to all of you? Can we proceed towards next out, beta? Everyone, just confirm me, beta. Can we proceed? Okay, crystal clear. Very good. Now, this one 147 and 148. So 147 and 148. 48 only. 148 only asked by Mehna. Okay, very good. Crystal clear, sir. Very good. See, beta, Mehna. I have one direct equation 2, but I'm not going to give you right now. Okay, I will give you after some time, because this time that you I want that you are going to use, just you use that conventional method. I want only conventional method used from your side this time, and I will tell you that direct method for first order reaction, that which equation you need to remember for examination, but not right now. So in an aqueous solution, reaction P forming Q occurs under isothermal conditions. First order, very good, first order kinetics, everything will be there. And now they are asking 5 liter CSTR replaced by 5 CSTR in series. See, in an aqueous solution, reaction P forming Q, that means epsilon A is 0, occurs under isothermal conditions following first order kinetics. That means, beta, you can write Ra is equals to K Ca. The feed rate is volumetric flow rate given na, 500 centimeter cube per minute. So should we write design equation 5 times and get the answer, sir? In examination, no. If it is first order reaction, then I will give you that direct expression. But if the order is not first order, like point 0.5 or any other order is there, then beta, you have to solve it step by step. Okay, only for first order reaction, one final expression is there that you need to remember, and that equation I will tell you later in non-ideality chapter. That derivation I will do for you. Okay, and I will show you how to you can remember that one. Okay, but for that short trick, all CSTRs must be identical, like in this case 5 CSTRs all of same 1111 liter. If here they are writing first is 1 liter, second is 2 liter, and third one is 2 liter, then that short trick is not going to do for you. That's why I'm not going to tell right now, but I will tell you later with their respective validity. Okay, so abhi yahan conventional method is taking, just see this with the help of conventional method, beta. Consideration of P in the feed. What is P? I don't want to write P. I don't want to write P. I want to write just A instead of P, because when I'm going to write P, it will definitely going to reduce our speed. Okay, because हमेशा A देखने की आदत है. So consideration of P in the feed is 1.5 into 10 raised to power minus 4 mole per centimeter cube. The reaction is carried out in a 5 liter CSTR. Very good. So volume is 5 liter. At a steady state, 60% conversion achieved. Rate constant asked. So first one is very easy. Just you have to write for this given case here, V by Fa naught equals to Xa by minus Ra, that is K Ca naught 1 minus Xa. So what is the value of V is 5. Fa naught is V naught into Ca naught, but no need to write that Ca naught because Ca naught will be cancelled here. If you are going to write V naught Ca naught, this Ca naught will be cancelled here, so no need to write that Ca naught. So it's just 5 by 500 equals to conversion is 0.5, no it's कितना 60 था ना यार, हाँ 60.6 upon 1 minus 0.6, that means 0.4, and upon k here, so write k here, and 5, this is 100, so write 100 here, write 100 here, and it will come how much here, 1.5, 1.5, it's 150 क्यों आने लगा रे भाई, वेट, थोड़ा कटिंग पिटिंग में लफड़ा हो गया लग रहा है, आराम से करते हैं इसे, इतनी भी शॉर्ट ट्रिक मारने की रिक्वायरमेंट नहीं है, वेट, see it again. So it's V by V naught, Ca naught, Ca naught, Ca naught cancelled. So K can be written as XA upon 1 minus XA and into V naught by V. Further solving, K equals to 0.6 upon 0.4, and what is the value of V naught? It's 500 C units centimeter cube per minute. Okay, and upon what is V? V is okay, it's 5 liter. So one conversion required, one conversion required here beta, one conversion required here, because here it's centimeter cube and here it's liter. So you know that 1000 liter is equals to 1 meter cube, or you can write 100 centimeter, 00 centimeter, 00 centimeter cube, that equals to 1000 liter. So 1 liter equals to clearly 1000 centimeter cube. So it can be written as 5000 centimeter cube. So you have to write here 5000. So 20 cancelled, 5 10 ja, and now it's 1.5 by 10, that means K is 0.15 minute inverse. So this is your first answer. B is the right answer. Now because reaction rate is not going to change for second case, and in second case you are going to rearrange 5 CSTRs of each 1 liter capacity. You are going to use 5 CSTR of same 1 liter capacity, all 1 liter, 1 liter, 1 liter, 1 liter, 1 liter. Okay, so one short trick is here, but that short trick will work only for first order reaction and equal size CSTR in series, equal size CSTR in series, and also for constant volume system. So here conversion is XA2, here it's XA1, XA2, and here it's XA3, here it's XA4, and here it's XA5. V naught, Ca naught. Clearly they are asking if the 5 liter CSTR is replaced by 5 CSTR in series, if the capacity of each new CSTR is 1 liter, the new overall conversion is. One thing you must see that the conversion must be more than 60%. But here all four options are more than 60%. So we can't say which one is correct before solving. So we have to solve. So for first CSTR, the design equation for all will remain same, that is V by V naught Ca naught is equals to XAF minus XAI and whole upon K Ca naught 1 minus XAF. Ca naught cancelled. That means for all cases we are going to use this design equation. This is the design equation that is valid for all these 5 cases. All these 5 cases. Okay, so now see for first one, it's V by V. On one more thing, beta, V by V naught is same for all cases here. So V is 1. What is V naught? But V is not 1. It's 1000. If you are writing in centimeter cube, so it's 1000. V is 1000 and V naught is 500. either change this or change that one. So it will be more beneficial if you are going to write this V naught here as 0.5 liter per minute. Okay, so V by V naught equals to XAF is we don't know, so that's XA1. XAI for first one is 0, and upon K just calculated it's zero point 0.5, and here it's 1 minus XA1. So 0 0.5, 50, 15, so I think it will come 0.3. It will come 0.3. XA1 by 1 minus XA1. Okay. Now you know short trick that XA1 can be written as 0.3 upon 1 plus 0.3. So it's 0.3 upon 1.3. Okay. Can you tell me answer? XA1 how much you are getting beta? XA1 बता दो जरा फटाफट हमें. Is it calcino? Tell me everyone. Main 0.23. Okay, very good. 0.23. Now, same thing you are going to do for next one. And you know, for all these cases, this is not going to change. It will remain zero point 0.3. Just this side changes. So for second one, in short trick, just by using some concentration, I can write zero point 0.3 is equals to XA2 minus 0.23 and whole divided by 1 minus 0.23. Okay. Sorry. 1 minus XA2. Now one equation, one unknown. Just solve it beta. So 0.3 minus 0.3 XA2 is equals to XA2 minus 0.23. Or further moving, we can write XA2 is equals to 0.3 plus 0.23 upon 1 plus 0.3. Or just you can write simply 1.3. 1 plus 0.3 will be 1.3 this here. And it is not going to change for all cases. For all cases, it will remain same 0.3 into this, and this will also remain same every time. So tell me again beta how much. Now see my short trick in examination. Now just by using some more concentration, I can add XA3, and now I can add XA3 is equals to XA3 is equals to this time 0.3 plus 0.4085. Only this thing will be changed ना, केवल यही तो बदल रहा है ना हर बार. Just this one is going to change every time. Like next term XA3 minus XA2. So now we know XA2. So XA3 here, XA3 here. Here XA2 will become. So this plus this by 1.3. Tell me this value बेटा. इसकी वैल्यू बता दो जरा फटाफट. 0.5450. Now for next one again you can write zero point 0.3 and plus 0.5450 upon 1.3. Tell me again how much. 0.65. Now again for XA5 0.65 plus this, so it's 0.95. So 0.95 upon 1.3. Tell me again how much. 0.7308. So clearly the answer is nearly 73%. So C is the right answer beta. Okay. So in this manner you can also use your concentration in examination, but only use if you are totally sure about your concentration, that you are using your mind in the right way and you are just going to do something in short manner with full confidence. Okay. So this is crystal clear बेटा. Can we proceed? क्या हम आगे बढ़ सकते हैं? ओके, यू नो वन इक्वेशन, टेल मी, ऐसा इक्वेशन किसी ने देखा है? एक्स इज इक्वल्स टू वन माइनस वन अपॉन वन प्लस टाउ वाई के रेज टू पावर एन। क्या है, ऐसा कुछ देखा है क्या आपने? क्या ये सही है जो लिखा हमने? पहले तो ये बताओ। हम्म। टेल मी। टेल मी आंसर। इज इट करेक्ट? शायद आपको दिखाया था ऐसा एक इक्वेशन। Is it CA by CA naught or is it XA expression? Tell me. जल्दी बोलो बेटा। Tell me answer by using this equation. Same to same. That means absolutely correct, yeah. Hmm? So this is valid only for first order. Same volume CSTR in series. एंड चलो अभी आपको दिखा देते हैं, क्या बाद में दिखाएंगे। सी, व्हेन यू आर राइटिंग फॉर कंसंट्रेशन फॉर initial concentration, that is CA naught, and concentration for nth reactor, so it will be simply C naught, and it will be C naught, it will be simply C naught, and it will be C naught or CA naught into 1 minus xn. So it's clearly 1 upon 1 minus xn, and this C naught by Cn can be written as C naught by C1 into C1 by C2 into C2 by C3 into C3 by C4 into C4 by C5. So by writing in this way, because here for this case we have 5, so this cancel. So clear C naught by C5 is there. Okay, C naught by C5 is there. And you know better that for every reactor, when you are going to write for this beautiful CSTR, then it's V by V naught CA naught equals to XA upon K CA naught 1 minus XA. And CA naught cancelled. This can be written as tau, so it's tau K. And you know XA can be written as tau K upon 1 plus tau K. ऐसा आता था क्या? कि कुछ गड़बड़ कर दिया हम लोगों ने? टेल मी, इज इट करेक्ट? Okay, correct. Very good. But here, when you are going to write for any given intermediate reactor, then in place of XA, you have to write XAF minus XAI. Wait, see again in terms of concentration. इसी को चेंज कर दें क्या? इसी को चेंज कर दो. See, if XA is K tau upon 1 plus K tau, then CA will be CA naught 1 minus XA, and XA is K tau bata 1 plus K tau. So here you can write CA naught 1 plus K tau minus K tau, that means 1 upon 1 plus K tau. So you can write beta CA by CA naught by CA is equals to 1 plus K tau. Okay, that means for every reactor the ratio exit in upon exit, see, in by exit, in by exit, in by exit, in by exit, in by exit. So you can write 1 plus K tau. So here you can write 1 plus K tau, but K tau 1, here 1 plus K tau 2, but every tau will remain same for this case because you are using identical CSTR, that is same volume CSTR in series. So here also you have to write 1 plus K tau, here also you have to write 1 plus K tau, here also you have to write 1 plus K tau. So you can write here that 1 plus K tau raised to power how much? 5, because here 5 CSTRs in series. If n, then here you have to write En beta. Okay, so further moving, that means you can write it becomes equals to 1 plus K tau raised to power n, and now just rearrange it and you can see beta. Then final conversion, that is xn, can be written as 1 minus 1 upon 1 plus K tau raised to power n. So this is your short trick, and this equation you can remember directly, you can remember. But see, it is only and only valid when you are using identical CSTRs, epsilon a equals to 0, first order reaction. Is it crystal clear to all of you beta? When you can use this short trick, its short trick validity, short trick validity is crystal clear to all of you. Can we proceed beta? Everyone please confirm me. सभी को क्लियर है ना? Crystal clear, sir. Okay. So see, next out 151. 151 was asked by, किसने पूछा था ये भाई? मेहना. मेहना बेटा, tell me your doubt in this question. इसमें क्या प्रॉब्लम आ रही थी बेटा मेहना? क्रिस्टल क्लियर सर, वेरी गुड बेटा मेहना. टेल मी दिस वन बेटा, इसमें क्या डाउट आ रहा था? दिस इज नथिंग, दिस इज वेरी वेरी इजी, सेम टू सेम क्वेश्चन, सिमिलर टाइप क्वेश्चन. यू वांट कंप्लीट सॉल्यूशन बेटा मेहना? चलो भाई देख लो भाई. A first order liquid phase reaction is carried out isothermally at a steady state in a CSTR. Okay, first order, it's very good. That means we can write RA equals to KCA. Okay, in a CSTR, and here the conversion that you are going to achieve is written zero point 0.9 with the same inlet conditions and same overall conversion. If the CSTR is replaced by two smaller identical, oh my god, that means again we can use that short trick here. Two identical CSTRs in series, okay, with the same overall conversion, that is XA2 equals to zero point 0.9. Then reduction in total volume, reduction is in total volume. If initially it is V, or you can write Vt, or just if you are writing V and now it is V1 plus V2. So just you have to check how much total decrease is there. So nothing special. For first case, write V by Fa naught equals to Xa upon minus Ra. Further moving, you can write here beta V by, no need to write Ca naught, Fa naught, directly just do it, zero point 0.9, and here it is K Ca naught 1 minus Xa, so the value of Xa is zero point 0.9. Okay, so V can be written as zero point 0.9 upon zero point 0.1, so you can write it's 9. You can write it's 9. So it's 9, and all constants like Fa naught by Kca naught. Okay, this is your equation number 1. Now for this case beta, for this given case you have to calculate V1 and V2. So first calculate V1. So V1 by Fa naught is equals to Xa1 upon K Ca naught 1 minus Xa1. Oh my god. Now what to do? We don't know about volume यार, अब क्या करोगे? But we know if we are going to calculate tau, tau will tell us V by V naught. So what to do now? Because we don't know this xa1 भी नहीं पता, but we know the overall conversion. So one technique is there that you are going to use reactor by reactor, and because just I discussed that short trick, so you can also use that short trick. Like you can write xa2 can be written as 1 minus 1 upon 1 plus k tau. What is tau? Tau is V by V naught. Okay, this one you can write like चलो इसे VT लिख दो, VT. So what is V by V naught? For both cases you know V1 is equals to V1 equals to V2. So for any reactor and it raised to power 2, Xa2 clearly you know, again it should be 0.9, 1 minus 1 upon, अरे ये क्या हुआ रे भाई, ये तो फंस गए हम लोग, because we don't know the value of K. अब क्या करें बताओ भाई? What to do now? K into K by V naught into V square. Further solving, it will be 1 minus zero point 0.9, that is zero point 1, and here you can write these all things here, and reciprocal will give you 10. So 1 plus K by V naught into V equals to 10, and you can write root 10. So K by V naught, or V equals to root 10 minus 1 into V naught by K, and this whole is, see, V naught Ca naught upon K Ca naught, clearly this is also V naught by K, so it can also be written as 9 V naught by K. And solve this beta, tell me how much it is coming. ये कितना आ रहा है? क्रॉस मल्टीप्लिकेशन वगैरह देख लेना, चेक कर लेना. Tell me how much it is coming. 2.1622. So 2.1622. So because this is just one reactor volume, so for second case, कलर चेंज कर किसी पेज पे कर देते हैं. For second case, if you want to see percentage reduction, so initially the volume is 9, and here V naught by K, V naught K cancel. So just you can write 9 minus 2 into 2.1622 and whole divided by initial 9 into 100. V naught by K, V naught by K you can take common from numerator, it will cancel from denominator. After solving, it will come 51.95. Is it correct बेटा? बोलो सभी को क्लियर है? Done बेटा. मैना, tell me बेटा. मैना, is it crystal clear? Can we proceed बेटा? Again nothing special यार. It's same to same question. Tell me बेटा. मैना, can we proceed? Crystal clear सर. चलो बहुत अच्छी बात है. So next one, 165 number. 165, Devarsh Agnihotri, asked by Devarsh Agnihotri and Shayan Mukherjee. Okay, see beta. Devarsh, are you there beta? Devarsh Agnihotri, are you there beta? Yes sir. Okay beta. See, this is desired reaction and they are asking the most favorable product distribution. The most favorable scheme is, okay, so they are writing this is desired one, this is undesired one. See clearly, if you are making a high concentration of E, it is going to favor undesired reaction, that is not good. And if you are going to use low concentration, then it is going to favor this reaction again. So clearly the desired condition is you want CD high and CE low. बोलो बेटा देवर्ष, यहाँ तक तो क्लियर है ना? Till now is it crystal clear? Can we proceed? Yes sir, crystal clear. Now see beta, CD high, C low. In the first case, clearly you are going to fed E and D both by same way. So clearly in this CSTR, the concentration of E and D both will remain same, because here clearly mentioned for processing equal molar flow rates of D and E. So equal molar flow rates. That means here if this is 10 mole per second, so this is also here you are going to write 10 mole per second. So clearly you are not using CD high and CE low. So first one is clearly wrong. In second one, the same thing, E is going here and D you are going to add here. Same to same, here also you can't use it, because here also CD and CE you are using both high. So clearly not correct. Now see, in this case you are sending all E initially here. It will make CE very high, and you are maintaining this 10 like 2 here, 2 here, 2 here, 2 here, or 1 point something here, 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 everywhere. So everywhere the concentration of CD will be low. Oh my god, it is going to favor undesired. So clearly it is also not correct. But if you are going to give D, all D initially to the PFR, it is going to make CD high. CD high. And now you are going to fed E little amount through many intermediate points in that reactor. So it is going to maintain what? CE low. That is our desired. So clearly C is the most favorable scheme. Is it crystal clear? Beta Devarsh Agnihotri, can we proceed? Can we proceed beta? Crystal clear sir, very good. And 166 asked by 166 कौन पूछा रे भाई 166 अनुष्का विश्वास and few more. Okay beta Anushka, are you there beta Anushka? Tell me Anushka, are you there? Anushka, are you there beta? Anushka Viswas, are you there beta? कितने बचे हैं भाई क्वेश्चन 66 68 2 3 4 5 6 7 8 8 questions and we have time approximately 1 hour left. Okay, आराम से हो जाएगा. If time left then we will also discuss few more concepts. चलो ध्यान दो बेटा इसे. This problem is also very easy. A first order irreversible liquid phase reaction A is forming B, reaction rate constant is given, is carried out under isothermal steady state conditions in the following reactor arrangement comprising of an ideal CSTR and two ideal PFR. Clearly you can see one CSTR and two PFR. What is the meaning of PFR using in series here? You can also write this analogous diagram. You can make one analogous diagram like this. Is there any problem beta? If we are going to draw like this and here we can write a PFR and this is a CSTR and in case of PFR 40 plus 60 100 liter volume. It is same to same na. Ditto, nothing change. Ca naught 1 mole per liter. Very good. And 100 liter per minute. Liter per minute, that means it is V naught. 100 liter per minute. Now can you tell me beta, in these two lines, what data is going to change? Ca naught or V naught or both? Ca naught or V naught or both? In these two branches. Tell me everyone, please tell me. In these two branches, what data is going to change? Is it Ca naught? Is it V naught or both? Very good beta mehna, kya baat hai, fantastic, mind blowing, super. It's V naught. So only you have to calculate how you are going to give V naught here and going to distribute V naught here. Because for both cases, Ca will remain same because it is concentration. It is concentration and before entering to the reactor, definitely the concentration will remain same like C naught, C naught. And one more thing written, see in both the lines, exit concentration is same, that is Ca. Here. So Ca clearly mentioned as 0.5. Here Ca also mentioned as 0.5. So clearly by mixing these two, we will get 0.5. If you want to write conversion, so no need to worry. Conversion here, it is from 1 you got 0.5, that means 50% conversion. Here also in this branch 50% conversion. So you can also write in terms of conversion. Now in this problem they are asking what should be the volume of CSTR in liter. What should the volume of CSTR in liter? So we have to calculate the volume of CSTR. Suppose directly I am going to use the design equation for this CSTR. So V upon V1, V upon V1, ये क्या हो जा रहा है भाई, V upon V1 into Ca naught. Okay, this is inlet molar flow rate equals to Xa upon first order na, so minus Ra, so minus Ra, that means K Ca naught 1 minus Xa. This is an equation you are writing for CSTR beta. Further moving, V Ca naught cancelled, so V equals to V1 into Xa upon K into 1 minus Xa. See, K value is given. Yeah, 0.1 minute inverse. So further moving, we can write V1 and Xa was 0.5. So 0.5 upon 0.1, 1 minus 0.5 will give 0.5. So this is V is clearly 10 V1. देख लो यार, सही है कि गलत है यार, कुछ गड़बड़ कर दिया क्या हम लोगों ने? V इज इक्वल टू 10 V1, कुछ गड़बड़ कर दिया क्या? टेल मी बेटा, इज इट करेक्ट? सही है? इज इट करेक्ट बेटा? जस्ट चेक. Okay, so that means in order to calculate the value of V, that yeah beta, V naught is the volumetric flow rate of feed beta. श्यान मुखर्जी, श्यान मुखर्जी बेटा, आप बीच में आते जाते रहते हो, पूरा का पूरा क्वेश्चन देखा करो बेटा, और लाइव क्लास में मत जाया करो, कोशिश किया करो ज़्यादा से ज़्यादा लाइव क्लास में रहो. ओके, अगर आपने सारी लाइव क्लासेस अच्छे से देख ली ना, रिवीजन बहुत कम करना पड़ेगा. सो V1 and V2, so just we have to calculate the value of V1, that's it for you, that will give you answer. So for that purpose, see this PFR, so you can write V by V2 Ca naught for this PFR design equation, and 0 to Xa is 0.5, and here dxa first order, so K Ca naught 1 minus Xa. This is for PFR. Okay, now here V is given 100, so 100 upon V2 into Ca naught, no need to worry, Ca naught cancelled, Ca naught cancelled. Okay, and K value is 0.1, equals to, its integration will be minus ln of 1 minus Xa, so its 0.5 lower limit will not exist because ln 1 will give you 0. Now just solve it and tell me the value of V2 बेटा. ये एक इक्वेशन है, जरा सॉल्व करो और V2 की वैल्यू बताओ फटाफट. टेल मी द वैल्यू ऑफ V2. $14.4269. 14.4269. Okay, so if V2, if you know the value of V2, then you know now that V1 plus V2 is going to make V naught. So what should the value of V1? V1 is V naught minus V2. What is V naught? V naught is 100. V2 is 14.43 approx. So it will come 85.57 approx in the same unit. So what should the value of this? 10 into 85.57. After solving, it will come 855.7 liter. This is your final answer beta. Tell me beta, is it crystal clear? Again, nothing special यार, कुछ था ही नहीं. Nothing special. Tell me everyone, is it crystal clear? Can we proceed beta? फटाफट बोलते चलेंगे everyone. Confirm? Okay, very good. Now, see this one, beta. A catalytic gas phase reaction P is forming Q is conducted in an isothermal packed bed reactor operated at steady state. The reaction is irreversible and second order. Okay, so the reaction is second order. So first data that we got, reaction is second order. So it's KCA square with respect to the reactant P. I am writing this as A is forming some product Q. The feed is pure P with a volumetric flow rate of 1 liter per minute and concentration of 2 mole per liter. In addition, use the following assumptions. The reactant product or ideal gas is very good. That means we can use PV equals to nRT if required. There is no volume change associated with the reaction. Very good. That means no non-ideality. If it is there, then you have to use solution thermodynamics. Ideal plug flow conditions prevail in the packed bed. Very good. So if they are not going to give these assumptions, still we are going to assume these all. When the mass of catalyst in the reactor is 4 gram. Okay. Mass of catalyst, that means W is given as 4 gram. The concentration of P measured at the exit. At the exit, that means Ca. And this is 0.4 mole per liter. The second order reaction rate constant K is. Now let me check unit first. So here liter square. Liter, no need to worry. And gram of catalyst inverse. So catalyst is in gram, no need to worry. It's mole inverse, yeah, mole, no need to worry. Minute. That means everything is very good for you. Just you need to write design equation and you need to solve. So it is packed bed reactor. So you have to write W by FA naught, that equals to integration of XA1 to XA2 dXA by minus RA. Okay. Okay, beta Shan, very good. So you have to put all values like W is 4 and no need to change any units, and V naught CA naught is FA naught, so it's 1 into 2. It's 1 into 2. The value of XA1 is 0. The value of XA2 is how much? C, because you are writing clearly P is forming Q, so epsilon A is clearly 0 here, and you know CA naught and CA. So clearly with the help of these two, you can write CA is equals to CA naught 1 minus XA, and CA is 0.4, CA naught is 2. So from here you can write what is the exit conversion. So 0.4 by 2, it will give you 0.2 is equals to 1 minus XA. XA will come 0.8. So here the limit will be 0 to 0.8. And dxa, first order, so K CA naught 1 minus XA. Further solving, you can write K here. K is equals to, this is 2 2s are 4. You can write 2. This side as 1 by 2. So 1 by 2 into this CA naught value is 2. And here it will be minus ln of 1 minus XA. So 1 minus XA, that means 0.2. It will give you final answer, beta. Tell me how much. Okay, beta. Tell me everyone. How much? What is the value of K, beta? 0.4024. ओके, पक्का? इसका 0.5 आंसर दिया हुआ है, कुछ गड़बड़ कर दिया क्या कैलकुलेशन में? हम्म, देखो जरा कुछ गड़बड़ हुआ क्या बेटा? सर बट वाई W? Mass of catalyst given na beta, mass of catalyst, and you are clearly mentioned that plug flow conditions are there. Okay, कुछ यूनिट का लफड़ा है क्या? लेट मी चेक. ओह हो, सी यहाँ मिस्टेक हो गया. सेकंड ऑर्डर है एंड वी सॉल्व बाय अज्यूमिंग फर्स्ट ऑर्डर है. बताते भी नहीं हो आप लोग. दिस इज स्क्वायर, दिस इज स्क्वायर. So now K will be 1 by 2 into 2 square, and here the integration will come 1 minus x raised to power minus 2 plus 1, and minus 2 plus 1 minus 1 खत्म हो जाएगा, and minus 2 plus 1 minus 1 यानी कि 1 upon 1 minus x है. एक बार मिला लेना यार. Is it correct? 2 to the 4 to the 8 and 1 upon 0.2 into 1 upon 1, sorry, minus 1 upon 1. So 5 minus 1 will be 4. Yeah, सही है. 0.5. And already we had seen unit was consistent, so no need to give extra time here. बोलो बेटा, सभी को क्लियर है? इज इट क्रिस्टल क्लियर बेटा? नो बेटा शिवात्रो, नो नीड टू मल्टीप्लाई विथ वॉल्यूम. इज इट क्लियर टू ऑल ऑफ यू? Crystal clear sir, very good. And this is what, how much r, this is r double dash ना? ये क्या r double dash है? Sir, can we solve for Vk and then divide by mass of catalyst? Shiva, no need to do long procedure beta. Okay, no need to do long procedure. Simple. As I told you, whenever they are asking packed bed reactor, the design equation for packed bed and plug flow reactor both are same to same. Okay, for every case, even if they are not going to give this, again you are going to use the same thing, because in that derivation, if catalysts are there, so you are going to assume again some volume here, similar manner, and this time not volume because just some catalyst is there, so you are using here the differential weight is dw. Previously it's dv, here you are adding just dw, so derivation will remain ditto, same to same. Okay, is it clear? Is it clear? And you're also assuming in all packed bed reactor plug flow is there. So if plug flow is there, but we are going to define in terms of dw. Okay, if you want to write in terms of volume of the reactor, again no need to worry, you can do this one also just by using simple mathematical things. Okay, because you know you can convert ra into ra dash into ra double dash into ra triple dash into ra 4 times dash. Conversion is definitely possible. So for the same given case, k you can write in terms of that catalyst per gram of catalyst, or you can also write in terms of per unit volume of that given reactor. ओके बेटा, टेल मी वन मोर टाइम, इज इट क्रिस्टल क्लियर? एक ही केस के लिए आप कितने भी फॉर्म में दे सकते हो. एंड यहाँ हमने कुछ बदला नहीं, क्यों? बिकॉज जस्ट आई हैड ऑलरेडी चेक्ड यूनिट्स कंसिस्टेंट विथ आवर डेटा. ओके, कैन वी प्रोसीड? The same thing beta you have to apply in examination so that you can save time beta. Okay, yes sir. चलो आगे देख लो. इसमें क्या प्रॉब्लम थी? दिस वाज द इजीएस्ट प्रॉब्लम. नथिंग हियर, कुछ था ही नहीं इसमें, तो कुछ है ही नहीं. ओके, हु आस्क्ड? 169. This one asked by Shyan Mukherjee. Devarsh Agnihotri. Okay, two names are there. That's enough. See, So both are present lives. That's good. See beta. A liquid phase irreversible reaction A is forming B is carried out in an adiabatic CSTR operating under steady state conditions. So nothing written special in this first line. Okay. The reaction is elementary. Oh my god. Here, if it is elementary, automatically you can write the rate expression as KCA. Because if this is elementary, so it is going to follow stoichiometry. And also written here, first order law. For this reaction, the figure below shows the conversion XA as a function of temperature. XA as a function of temperature. That means at different temperature, what is the value of XA? For different values of rate of reaction. Oh my god, that means if rate of reaction is 1, then you have to follow this graph. If the rate of reaction is 2, you have to follow this graph. And same to same, you can see all graphs. In mole per meter cube per second rate, denoted by the numbers to left of each curve. Okay. This figure can be used to determine the rate of reaction at a particular temperature for a given conversion. The inlet stream doesn't contain B. That means only A and B is there. If inlet is no B, that means pure A. And inlet concentration given 5. So it's Ca naught and that is given as beta 5 mole per meter cube. The molar feed rate of A is molar feed rate of A, that is Fa naught, and this is 100 mole per second. A steady state energy balance for the CSTR results T equals to 350 plus 25 XA. Very good. That means if we know conversion, we can get temperature. Once we get temperature, with respect to that conversion, we are able to understand on which graph, on which curve we have to use. Now, next line. For an exit conversion of 80%. Okay, this is the 80% line. This is the 80% line. The volume of CSTR required is. कोई दिक्कत नहीं है, फटाफट देख लो, फटाफट देख लो. This is your CSTR in out. So for volume, first you want a conversion value. Conversion given 80%. Very good. So what should be temperature inside? 350 plus 25 into 80. That is 0.8. So it's 370. Where is 370? So 1, 2, 3, 4, 5. Every this line show you 5. Increment of 5. So 375. So it's 370. This point is going to give you beta value 370. Okay. Now according to this and the given conversion, now you can see we are getting this point. So what should be the rate of reaction that you are going to use? That is 10. Now no need to see graph again. You got the value of rate of reaction in the same unit, mole per meter cube per second. Now you know the design equation beta, that is V by F A naught is equals to X A upon minus R A. Now what is the value of V? V is X A into F A naught upon minus R A. What is the value of X? 80% conversion, 0.8. What is the value of Fa naught? It's 100 mole per second. 100 mole per second. Mole per second. So you want mole per meter cube per second, na? See rate unit. Mole per meter cube per second. Yeah, that means you are going to get volume in meter cube. And they are also asking in meter cube. So no need to see units. So Ra that you are going to use here is 10. So 10 tens are 100. And 10.8 will give you 8. So 8 meter cube is the right answer. बोलो बेटा, इज इट क्रिस्टल क्लियर? कितना आसान है देख रहे हो. and because I am able to concentrate on units, so I'm not going to write units here beta. But if you're not able to concentrate, and even if you're going to do mistake when you're going to solve at your home or in test series one or two times, then beta please in examination don't forget to check units, unit को लिख लिख के करने का. Okay, is it clear to all of you, my dear students? Can we proceed? No doubts? Very very easy. Shian Mukherjee, Devarshak Nihotri, tell me beta, is it clear? Crystal clear sir, crystal clear sir, crystal clear sir. Okay, now this one asked by, छोड़ो क्या ही नाम लिखे, सी फटाफट देख लो, बहुत ही आसान क्वेश्चन था, इसे क्या ही पूछने की जरूरत थी. है द फॉलोइंग कर्व शोज यू 1/RA versus XA. Here RA XA represent reaction rate and conversion respectively. Pure A feed and zero point 0.9 conversion required. 0.9 conversion required. So best combination they are asking you. Okay. Which one amongst the following rated configuration is going to give you the lowest total volume? Clearly here no need to see order, because one time clearly negative order and one time positive order is there. Let me check beta. So see, up to this point, if you are going to use PFR, then it is not good. So if you are using CSTR, then only this volume required. No need to see this. First see, is it 1/RA versus XA? Yeah, it's 1/RA, because sometimes in examination they can give you RA versus XA. Okay, and now here if you're going to use CSTR, this is extra volume, so no, it's not CSTR, it's PFR. Yeah beta, very good, very good. It's CSTR followed by PFR. CSTR followed by PFR. A is the right answer. Is it crystal clear to all of you beta? Can we proceed, my dear students? It is going to give you lowest total volume, and maybe sometimes then in examination they can write here the highest total volume, in which case you are going to get. So please be careful and please read question clearly. Okay, done. Chalo, very good. This one was homework question of I think a previous lecture, but still someone asked here. कौन पूछा रे भाई इसको? Hmm? 195. Shayan Mukherjee, Shiva Tarun. Shayan Mukherjee and Shiva Tarun. Two students. Shiva Tarun and Shayan Mukherjee. चलो भाई देख लो, इसमें भी कुछ नहीं है. कितने क्वेश्चन बचे हैं? एक दो तीन चार, चार बचे हैं. आई होप these four questions we will able to do. Still we have 35 minutes left. At 30 degree Celsius, the amounts of acetone, चलो इसे पढ़ लो थोड़ा, बहुत लगातार आपको बता रहे हैं. आई एम गिविंग यू 1 मिनट ब्रेक. ओके, जस्ट रीड इट, 1 मिनट ब्रेक, क्योंकि बहुत जल्दी जल्दी एक्सप्लेन कर रहे हैं. सो आपके दिमाग को थोड़ा सा आराम दे देते हैं, बिकॉज दिस इज डाउट क्लियरिंग सेशन, इसलिए फटाफट सॉल्व करते जा रहे हैं बेटा. समय बीच में स्टॉपेज नहीं दे रहे आपको, बिकॉज दिस इज डाउट क्लियरिंग सेशन. I am giving you 2 minute break, and in that break just extract data here of this question and try to solve. This is adsorption isotherm question beta. 30 degrees Celsius is there, Langmuir isotherm clearly mentioned there. Okay. So everyone ready? Please tell me in comment section, beta. Just right, ready. Can we proceed? Can we proceed, my dear students? सभी लोग बोलेंगे पूरी एनर्जी के साथ बेटा. Please tell me everyone. Please tell me everyone. Ready, sir? Okay, very good. So at a 30 degrees Celsius, so the temperature, my dear students, here clearly mentioned at 30 degrees Celsius. Okay. So at 30 degrees Celsius, the amounts of acetone adsorbed at partial pressure of 10 and 100. Clearly, if more partial pressure, more amount adsorbed. So zero point 0.1 C corresponding to this 10 and corresponding to this 100, it's zero point 0.4. Okay, if it is below equilibrium pressure, then by increasing pressure you can increase same to same concentration. Itna, that means when the partial pressure is 10 mmHg, then every kilogram activated carbon is going to adsorb zero point 0.1 kg of acetone. Okay, let me write here beta. So when the partial pressure is how much? 10 mmHg, corresponding to this, the amount that can be adsorbed is given as zero point 0.4 per kg activated carbon. Okay, so amount that can be adsorbed. So it is in adsorbed form. So this is the value of CAS, adsorbed on that side. And it is written as zero point 0.4 kg acetone per kg activated carbon. Okay. And when the partial pressure increases to 100 mmHg, then the value of this adsorb acetone in the same unit is now, oh sorry, the first one was zero point 0.1, the second one was is a 0.4, so it's 0.1 and it's 0.4. See, it's 0.4 and the first one was 0.1. And now they are asking what should the amount at 30 degrees Celsius adsorb. So temperature is clearly same, and it must be same if you are using isotherms, because isotherm means at isothermal condition. So they are asking if you are going to use partial pressure as 50 mmHg, then what should be the value adsorbed in the same unit? See, in kilogram per kg of activated carbon. So we have to use Langmuir isotherm. It is mentioned. It is clearly mentioned in our problem that we have to use Langmuir adsorption isotherm. And just you had completed this topic here. So I hope everyone remember the equation. That was this theta is equals to Ka Pa upon 1 plus Ka. Now, can you tell me this phi represents this theta represents what? This is fraction of site occupied, or is it vacant fraction of sites? ये क्या था? What was this phi? Phi क्या था बेटा? Fraction of site occupied or vacant site fraction? Last lecture में यही पढ़े, previous lecture occupied fraction. So this is fraction of occupied site. Occupied site. So clearly you can write this equation again as CAS by CT. That means the max concentration that can be adsorbed there, suppose it is given as CT for every kilogram of activated carbon, because we are not going to change units. Unit of CT and CS will remain same. So how much it is going to adsorb there if the total is CT? It is clearly going to depend upon partial pressure. So now clearly here you can see this beautiful equation. And now just if you are going to write the value of CT here, the value of Ka here, and the value of Pa here, you will get the value of that CAS here. but we don't know the value of Ka and we also don't know value of Ct. What is the value of Ct? That is the maximum amount that can be adsorbed there when all sites occupied of that activated carbon. So no need to worry. Make equations and solve. So for from this first one you can write here equation as point 0.1, that is CAS upon CT, and that equals to, what is the value of K? We don't know, but PA is 10. So 10 Ka upon 1 plus 10 Ka. Now for second one, it's zero point 0.4. Ct will remain same because that is the max that can be adsorbed. And this time the pressure is 100, so it's 100 Ka upon 1 plus 100 Ka. Now just divide these two. So Ct cancelled. Zero point 0.1 by zero point 0.4 will give you 1 by 4, that is 0.25, and that becomes equals to 10 is going to cut this to 10 times. So you can write 1 plus 100 Ka and whole divided with 10 Ka into 1 plus 10 Ka. Okay. Now just to use cross multiplication. Before that, please open the bracket. So 0.25 is equals to, this is also cancelled, 0.25 equals to 1 plus 100 Ka divided by 10 Ka plus 100 Ka square. Now cross multiply. 100 Ka square into 25 will give you 25 Ka square, and 10 into 0.25 will give you 2.5 Ka, and equals to 1 plus 100 Ka. कुछ कैंसिल और हो रहा है? अरे हाँ, के भी तो कैंसिल हो गया है भाई, इसको क्यों लिख रहे हो वापस से? इसको तो लिखने की जरूरत ही नहीं है ना. के ओह 10 के, अच्छा ये सही है, ये के नहीं होगा यहाँ. वेट 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 वेट, ये रहेगा, ये नहीं रहेगा, इसीलिए ये इतना बड़ा बन रहा था. भाई हमने कहा इतना बड़ा क्यों हो रहा है यार, सेकंड पावर का क्यों हो रहा है? जल्दी जल्दी के चक्कर में वो स्क्वायर छूट गया. इसे मिटा दो, फटाफट देख लो यार. नाउ व्हाट विल वी गेट? एक बार फिर से रीचेक कर लो यार. के कैंसिल्ड, 10 जा 100, ओके, नथिंग एल्स. सो 0.25 equals to, this will go numerator, okay, and 10 into this one, सही है. So 0.25 into 10 plus 100 Ka equals to 1 plus 100 Ka. Open bracket बेटा. 2.5 plus 25 Ka equals to 1 plus 100 Ka. 2.5 minus 1 will give you 1.5. 100 minus 25 will give you 75. This is the value of K. यही आ रहा है ना, देख लो आराम से. Is it same? So after solving, what is the value of Ka? K कितना आ रहा है बेटा, देखो जरा. 15 by 750. 15 5 जा 70. 1 by 50.02. यही आ रहा है ना. Very good, very good. So once you got the value of K, now put in any one to get the value of Ct. Like if I'm putting here, so it's 0.1 by Ct. 0.1 by Ct equals to 10 Ka बटा 1 plus 10 Ka. So 10 Ka बटा 1 plus 10 Ka. So Ct can be written as, छोड़ो डायरेक्ट करने की जरूरत नहीं है, फिर गड़बड़ ना हो जाए. So it's 0.2 upon 1.2. So Ct will be 0.1 into 1.2 upon 0.2. So cancelled. Ct will be 0.6. Please recheck beta. एक बार रीचेक कर लो जरा इसे भी, के पी ए वैल्यू और सेम ना? If it is same, so now you know CAS by CT equals to KA PA upon 1 plus KA PA. So CAS equals to CT. What is the value of CT? It's 0.6. KA. KA is 0.02. And now you have to calculate at 50 mmHg. So 1 plus 0.02 into 50. Okay. So zero point 0.6 into 1 by 2, 0.3. Answer. Is it same? बोल रहा सभी को क्लियर है? Is it crystal clear to all of you? Is it crystal clear, beta? Can we proceed? So the right answer is C. C is the right answer. Okay. चलो. So इसको भी पूछोगे या लगा लिया? इसमें से कुछ है ही नहीं, इसको क्यों पूछ दिए? What is the problem here, बेटा? 197 किसने पूछा भाई? ज़्यादा से ज़्यादा क्वेश्चन डिस्कस करने में यार आज तो मेरी उंगली की बैंड बज गई यार, दर्द होने लगा जल्दी जल्दी लिखने से. 97 श्यान मुखर्जी, देवर्ष अग्निहोत्री. ओके, तो इसे भी लगा दें यार. टेल मी, यू वांट सॉल्यूशन? देवर्ष अग्निहोत्री एंड श्यान मुखर्जी. Sir, intervention CT was number of total active sites. CT is total concentration of sites, beta. Total site concentration. Okay. सर आंसर नॉट गिवन. सर फाइनल आंसर. अच्छा, इसका केवल आंसर चाहते हो बेटा? रेट एक्सप्रेशन ऑलरेडी डेवलप्ड बाय यू. ये तो आपने निकाल ही लिया था रेट एक्सप्रेशन. यू डेवलप्ड. This was already developed. Now that's why I told you no need to develop. You have to write the answer there. So after getting that rate expression, and when you are going to put values, so it will come 0.553 into 10 raised to power minus 4 kilomole per meter square per second. I told on Telegram that you have to calculate the value of rate in this question, beta. So is it same? If same, then confirm me. Otherwise, I have to solve it. सेम बोल दो तो मजा आ जाए यार. पूछोगे तो सॉल्व तो करना ही पड़ेगा. सेम सर, क्या बात है. वेरी गुड शिवा तरुण. सेम, क्या बात है. देवर्ष अग्निहोत्री सेम. सो नो डाउट्स. दैट मीन्स नो डाउट्स बिकॉज हियर जस्ट यू हैव टू पुट वैल्यूज यार. You have to put values. Okay. Sir, concentration unit we can write in kg. Where beta? For which case? For this case? Yeah beta. Concentration you can write in any unit beta. You can write in any unit. That is the concentration means what? Just how much site occupied you are going to write. So clearly you can write kg adsorb per kg. So here concentration in terms of that solid form. That is not for liquid. Okay. Is it clear beta maina? Okay sir, very good, very good. Sir, could not interpret given data as CAS, sir. Here beta CAS is not given. CZ is not given kya? CZ. Gaseous reactant, diffuser reactant, reactant, the reaction rate, the gas film mass transfer coefficient, derive the bulk concentration. This one. No need to worry beta. No need to use different notations for these type of questions. Every time just use a same to same representation beta. It will increase your speed. As in previous case you had seen they are writing P is forming Q, but I am assuming A is forming B, and I am extracting all data in terms of A. Okay. Can we proceed beta? इसमें किसी को डाउट नहीं है? आई थिंक द आंसर विल बी इतना टाइम सीजी, यहाँ सीजी भी आएगा ना, एक बार देख लेना जरा, यही आ रहा है क्या? बिकॉज सीजी इज नॉट हियर ना, सीजी तो है ही नहीं. हम्म. इज इट सेम? या वेरी गुड, वेरी गुड. बिकॉज सीजी वैल्यू इज नॉट गिवन इन द प्रॉब्लम ना. क्या दास सर एक्सप्लेन करो दिस वन बेटा, यू वांट एक्सप्लेनेशन? सी बेटा क्या दास, नो नीड टू वरी, जस्ट फोकस हियर. यू नो व्हाट वाज द रेट, ओवरऑल रेट? ये तो आपने निकाला था ना, रेट, ओवरऑल रेट. हम्म. ये क्या आया था? रिमेंबर्ड? के वन के एम अपॉन के वन प्लस के एम इंटू सी जी. दिस इक्वेशन वॉज डेवलप्ड बाई यू. ये डेवलप किया था ना, बिकॉज यूर क्लियरली मैंशनड फर्स्ट ऑर्डर के वन सी एस. And now just you have to write that cs in terms of cz, and already you had done, you had written k double dash or k dash upon kl plus k dash into cz. Tell me beta kya das, is it clear? Is it clear beta? And see km, and here unit is same to same, so k1 can be added in km. So just write here 0.83. Yes, sir, clear. Very good. Into 10 raised to power minus 4 into 1.66 into 10 raised to power minus 4, and whole divided by 1.66 plus 0.83 and whole into 10 raised to power minus 4. Just add it into CG. This cancelled with this. After solving, I hope that you will get directly this value. Is it clear, beta? Kya das, tell me, is it crystal clear? Yes, sir, clear. Very good. See this one. ये किसका डाउट था बेटा? 198 नंबर. मेहना. ओके बेटा. सी बेटा मेहना, प्रॉब्लम इज वेरी वेरी इजी. इट्स वेरी वेरी इजी. ओके. For a heterogeneous catalytic reaction A plus B forming C, A plus B forming C, okay, with equimolar equimolar feed of A and R. R कहाँ से आ गया रे भाई? सॉरी, ये गलती से R लिख दिया. दिस इज B. Okay, this is B. Now, initial rate RA naught is invariant with total pressure. What is the meaning of invariant, beta? Invariant समझते हो? What is the meaning of invariant? Invariant with total pressure. Can you tell me the meaning? Can you tell me, beta? It is independent to pressure. Invariant means independent to total pressure. Is it correct? Confirm me, everyone. Not dependent. Okay, okay, very good. So the rate controlling step is, if these are active sites And in your problem, it is clearly mentioned by changing total pressure. By changing total pressure here. Total pressure means what? It is going to change PA and PB, and clearly mentioned feed is equimolar. That means same A and same B is there in the feed. So the probability to adsorb will remain same by increasing or decreasing pressure. And here they are asking which one is rate controlling. If initially by changing this P, even if we are changing increase this or decrease this, the occupied how much, what is the rate of reaction, it is not going to change. ये रेट ऑफ रिएक्शन चेंज ही नहीं हो रहा है प्रेशर को बढ़ाने या घटाने से, मतलब पार्शियल प्रेशर ऑफ ए एंड बी को बढ़ाने या घटाने से. दैट मीन्स क्लियरली माय डियर स्टूडेंट्स द रेट इज इंडिपेंडेंट ऑन पी एंड पीबी. What does it mean? Surface reaction between adsorb A and B in the gas. Why? What is the meaning of this surface reaction of adsorb A and B in the gas phase? If you are using B in the gas phase, or either if you are using adsorb A is there, clearly mentioned that the rate is invariant with the total pressure. That means rate is independent on A and B. A and B का तो कोई रोल ही नहीं है भैया. There is no role of A and B. So clearly the rate determining a step is not relating with A and B, because clearly mentioned the total pressure, even by changing total pressure, the rate is not going to affect. If rate is not going to affect, what does it mean? That means clearly you can write like it is a zero order type reaction. That means the rate is not going to depend upon either the PA or either PB. इस PA और PB पे डिपेंड नहीं कर रहा, ये तो मतलब हुआ ना बेटा. Are you getting it? Please tell me yes or no in comment section बेटा. Are you able to understand? Confirm me everyone. Are you able to understand? Can we proceed? If you are changing P, still rate is same to same. It's invariant. Yes, sir. Very good. So if you are writing A reaction surface reaction, no, it's not correct. It's not correct. Again surface reaction, it's not correct. So clearly it's desorption of C. This is the rate controlling step now. Why? Because if A is here, if B is here, after some time, if they are going to convert it into C, and if C is not going to dissolve, my dear students, so all sites will be occupied by C. It is going to affect how efficiently A and B is going to adsorb there. So clearly how efficiently C is going to dissolve from the surface is going to control your rate. So its desorption of C is the rate controlling step. Is it crystal clear to all of you, beta? Please tell me everyone. Can we proceed? Confirm me, beta. Can we proceed, my dear students? Crystal clear. Everyone, please tell me, beta. Crystal clear, sir. Very good. Mehna, sir, but initial rate is independent. Can we say anything rate is constant? Beta, it is written initial rate. What is the meaning of initial rate? Initial rate means T is 0. No. Initial rate, if you are writing RA, it's not T is equals to 0. No, this is wrong. RA, when T tends to 0, just time is started. That was initial rate. And you are seeing that initially, clearly, it is not going to affect. However, you are going to change the total pressure. That means by changing PA and PB value, the rate is not going to change. That means what is going to affect the total rate there? Clearly, it is the desorption of C, because only C is still there. A and B, they are reactants. So desorption of product is the rate controlling step there. Is it clear, beta maina? Beta initial rate you can't say. Why you are telling any time initial rate, beta maina? Initial rate means when T tends to 0. Initial rate means T tends to 0. If you are dealing after some 50 minutes and you are telling that one as initial rate, that times many sites are occupied by that C. Are you getting it, beta? So initial rate means when T tends to 0. And clearly when you are going to derive it, beta, during derivation, uh, PA and PB will not be there. PA or PB वहाँ नहीं होगा. In denominator, the thing that is going to reduce the rate, that will be the partial pressure of that C. Can we proceed, beta Mena? Please write crystal clear one more time. Tell me, beta, you want one more time explanation or is it crystal clear? Yes, sir, one more time, please. See, beta. Option A. It is written surface reaction between adsorb A and B in the gas phase. This statement is not true. This is clearly false. Why it false? Because when you are going to increase or decrease total pressure, clearly it is going to increase or decrease respective partial pressures of A and B, and definitely they are going to affect the rate there. If you are writing that surface reaction is rate controlling step, so clearly A can't be correct. See B option, surface reaction between adsorb A, adsorb B. Again, this is not true. Why? Because again, by increasing or decreasing total pressure, corresponding you will increase or decrease respective component partial pressure, and again my direction the same thing is going to happen. If this is the rate controlling step, by increasing or decreasing pressures, partial pressures, or in terms of concentration, if you want to see Pa by RT is concentration, so you can also see synonym like concentration, and logos in log concentration just like partial pressure. So clearly if the B is correct, so partial pressure, or you can say total pressure, by changing total pressure the rate will change. But here clearly it is not mentioned. They are writing that rate is invariant. So B is also false. C is also same to same beta. Surface reaction between A in the gas phase and adsorb B. Again the same thing here. If A or B, because they are mentioning equimolal. So either A or B in adsorb form or in the outside. If it is not going to affect, that means the rate is not going to control by the partial pressure or total pressure there. That is clearly is going to affected by only and only the product, how efficiently the product is going to dissolve. प्रोडक्ट जितना जल्दी डिजॉर्व होगा साइट को छोड़ेगा, ए और बी वहां बैठ पाएगा. ए और बी जितना भी तेज बैठ सकता हो बेटा, अगर उसको बैठने की जगह ही नहीं देगा, हर जगह प्रोडक्ट बैठा रहेगा, तो कोई मतलब है? आप प्रेशर को बढ़ा लो घटा दो, स्टिल आपका सेम रेट ही रहेगा, क्योंकि ए और बी के बैठने का तरीका वही है. अब कितना स्थान उसको आप दे रहे हो बैठने के लिए, ये किस पे डिपेंड करेगा कि सी बनने के बाद से कितना जल्दी अपने प्लेस को छोड़ रहा है. हाउ इफिशिएंटली सी इज गोइंग टू डिजॉर्व आफ्टर producing, जैसे बन जा रहा है. once C produced, how efficiently it is going to dissolve from the given site, respective site. Crystal clear, sir? No, chalo, very good, very good. And I think this is final question. Yeah, very good. And still we have 3 minutes left. Okay, चलो थोड़ा 5-7 मिनट बढ़ जाएगा, देख लो इसे भी. And this was asked by 199. किसने पूछा रे भाई? 199. सोचा था कुछ एक्स्ट्रा डिस्कस कर देंगे आज यार, लेकिन टाइम तो बचा ही नहीं. कोई बात नहीं. श्यान मुखर्जी, देवर्ष अग्निहोत्री. श्यान मुखर्जी, देवर्ष अग्निहोत्री, आर यू देयर बेटा? दिस इज जस्ट अ कन्वर्जन बेटा, ये केवल एक कन्वर्जन है और कुछ भी नहीं है. दिस इज जस्ट अ कन्वर्जन. नाउ सी, hydrogenation of benzene is to be carried out using nickel density given. Okay, So density given 8910 kilogram per meter cube. Okay. As catalyst, hydrogenation of benzene is to be carried out using nickel. This density of catalyst cast in a form of non-porous hollow cylinder. Okay, so it is non-porous, so you are using like a hollow cylinder. So this is the catalyst. ये आपका catalyst है बेटा. A cylinder hollow cylinder. This is your catalyst. So catalyst is non-porous. So you are using catalyst like a hollow cylinder. The reaction occurs on all the surfaces. All the surfaces, that means what, beta? What is the meaning of all the surfaces? That means this curved surface, this top surface, and same to same this again on bottom side it is also available, na beta? So that means curved surface and into this multiplied by 2. This is the total surface area. Okay. During an experiment, one such cylinder is suspended in the reactant stream if the observed rate is. So observed rate is 0.39 mole per meter square of catalyst surface per minute. Okay. Then the rate of reaction in mole per kilogram of catalyst per minute. It's very easy. Just you have to convert one RA in the other form here. And you know na, you know that this is clearly RA single dash multiplied by surface area. That can be written as RA double dash into W. So here you have to calculate this RA double dash. So RA double dash can be written as S by W into RA dash. RA dash you already know. Now just you need to calculate what is the total surface area and what is the total mass there. Total mass how to get, sir? By multiplying with density. Volume multiplied by density. आर यू एबल टू अंडरस्टैंड बेटा? समझ में आया कि इसको क्या करना है, कैसे सॉल्व करना है? इफ यस देन स्टार्ट सॉल्विंग फॉर सरफेस एरिया. पहले बताओ ये समझ गए ना हाउ टू सॉल्व इट? इज इट क्लियर? फटाफट बता दो, सॉल्व कर देते हैं. कोई दिक्कत नहीं, टाइम इज वोर बट स्टिल वी कैन एक्सटेंड 5 to 10 minutes. टेल मी बेटा एवरीवन, इज इट क्लियर? Clear, sir. Very good. So what is the value of surface area? Total surface area. Be careful, be careful. So curved surface. So total surface area can be written as curved surface, that is pi dl. Okay, pi dl. And wait, inside भी तो होगा ना, inside and outside two curves are there ना, two curves are there. So it's pi d inside into l plus pi d outside into l. This is curved surface area. And now 2 multiplied with pi by 4 d naught square minus pi by 4 di square. Because if this is your circle, so first calculate this complete area. This complete area is pi by 4 d naught square. And now just calculate this area, that is pi by 4 di square. And if you are subtracting this from this, then you will get this area. Okay, so area का formula सभी को clear है बेटा? Tell me everyone, is it crystal clear to all of you? Area formula is crystal clear to all of you? Very good, very good. निकाल भी दिया आपने, क्या बात है यार. So it can be written as pi l into di d naught. क्या क्या है values दिया हुआ देख लो यार. So di is given as 20 mm. Here they are writing meter square, so convert in all things in meter square. So it's 0.02 meter. D naught 0.02 0 to 5 meter, and L this height 0.025 meter. So just put all values here. So surface area 80 means what? Surface area. Pi L we can take common, di plus d naught. So pi into L di d naught. So di and d naught डायरेक्टली लिख सकते हो 20 25 45 mm. So 0.045 in terms of meter, plus this is curved surface area. This is curved surface area. Now plus 2 multiplied with pi by 4 d naught square. So 0.025 square, 0.025 square minus pi by 4 0.020 square. Now this is top and bottom side area. Tell me how much Siva Tarun had written one value, 3.888 into 10 raised to power minus 3 meter square. Now you have to calculate volume now, because you know volume multiplied by density will give you mass. So how to get volume? This is volume. So first calculate this surface area and extend this surface area up to this height. So what is this surface area? This, only this, inside this. So it's pi by 4 d naught square, pi by 4 di square, and multiplied with L. What is L? L is 0.025. This is volume. And volume multiplied by density will give you mass. So multiplied with density. How much density is there? In the same unit you want, na? So kilogram per meter cube, no need to worry. So 8910. Tell me beta. Tell me weight. How much? 0.0394. 0.0394 kg. Okay, very good. So now what should be our answer beta? RA double dash will be S by W. So 3.888 into 10 raised to power minus 3 divided by 0.0394, and here RA was 0.39. 0.39. Tell me beta answer. How much? 0.0385, and unit will be what? Unit will be mole per kg per minute. Mole per kg per minute. Okay. Now they are asking in our problem rounded off to 3 decimal places. So you can write as 0.038. This is your final answer. ये 5 के आगे अगर 50 ज़्यादा है तो लिख सकते हो एक बढ़ा के भी, but no need to worry. In your examination still you are in the range. Okay. Because for this question range given was 0.03 to 0.043. 0.0342 0.043. This was the range given by GATE. Okay. Is it crystal clear to all of you beta? Tell me everyone. बहुत सारा क्वेश्चन डिस्कस कर दिया गया आज हम लोग, बड़े बड़े क्वेश्चन बहुत ही कम समय में डिस्कशन किया. आज उंगली की हमारे बैंड बज गई, बहुत ज़्यादा लिखना पड़ा जल्दी जल्दी. But I hope that I able to explain all things in such a manner so that there is no doubt left. बोलो बेटा सभी को क्लियर है ना? कोई डाउट तो नहीं बच गया ना? All things are crystal clear, my dear students. Please confirm me, everyone. डन। सो चलो एक बार शुरू से देखते हैं, जस्ट 1 or 2 more minutes बेटा, जस्ट आई वांट टू शो यू that the doubts that you asked are actually no, not a doubt, not a special thing that you asked. Just if you are going to revise your notes, or just if you are going to try to make more concentration during solving a problem, clearly these problems you all able to solve यार, ये फंसने वाला क्वेश्चन कुछ है ही नहीं. Like see this one, nothing is special. This nothing is special, just use simple things. So just you have to thought like this beta. Here also nothing is special. In this also you had seen similar thing, just you have to make, and just trial error method is there. Here also same simple balance is there, nothing is special. This one just you have to solve that differential equation, because you know for batch reactor just you need to solve rate expression that will give you directly answer. Here also nothing is special here. In this problem I told you two techniques, one conventional technique and the second one that short trick you can use, but that short trick will be applicable only and only for identical CSTRs in series for first order constant density system. Okay, then you had seen this one is also very easy, just two cases are there, just you have to compare volumes here. This one is also very easy, just you have to see CD high and C low, in which case you are going to maintain that. This one is also same to same. You want to calculate the volume of CSTR, definitely if they are writing this way. So just they are writing the things in such a manner, like two statements they are writing in terms of a diagram. वो एक diagram के form में two statements को लिख रहे हैं. Okay, so 2 PFR, no need to worry, you can use same 1 PFR of 100 liter volume, and some unknown is there in that line that you are going to get from the other line. It is clearly your in your thought before solving this question. So first you have to write what required. So I started for CSTR, and now I can see I need V1 there. So for that V1, write design equation for that PFR. Okay, in this one just by using writing that assumption, they are trying to just increase the length of question. They just trying to check that you are able to concentrate or not if the long data is there. Okay, so nothing is special also, see how easy solution is. This one very big question, you feel, but easiest question. Okay, this one is also very easy. Here also the same thing, simple mathematics is there by using your expression, but just you need to remember that expression here. And this one also you had seen simple formula based question. This one is also very easy. This one is same to same, just a conversion there from I think this is from our lecture number 1, starting lecture 1 or 2, where you had seen RA V equals to RA, yes, RA W RA VR from that lecture. Okay, so tell me what all things are crystal clear now. So at last I want to say the same thing, my dear students. If you want the good rank beta in examination beta, then you know the revision is the key. Revision is the key. So don't forget to revise your notes every day beta. I must do my revision daily. 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 In this manner, definitely you are going to get rank 1 to rank 100, or any rank between these ranks, definitely or nearby, is going to make a beautiful path for your dream job beta. So all the best beta, take care, love you all, and a very happy good night to all of you. ओके देन बेटा, सभी ने एंजॉय किया, मजा आया सभी को, नो डाउट्स? सो तैयार हो नेक्स्ट लेक्चर में आगे के कंटेंट को, आगे के चैप्टर्स को कंप्लीट करने के लिए? एवरीवन रेडी फॉर नेक्स्ट लेक्चर? थैंक यू सर, थैंक यू सर, एंजॉयड सर, मी टू बेटा, मी टू एंजॉयड टू मच. ओके बेटा, टेक केयर.